Hello mga ka-try! Welcome to episode 10 of Try Robotics. Last week, we programmed our K-12 robot to do an obstacle avoidance. So we used our motors, our ultrasonic sensor, as well as its headlight LEDs. Tonight, we'll be learning to use the speaker of our K-12 robot. And we will use the different sounds that are pre-programmed in our K-12 robot. Aside from that, we will also program our K-12 robot as a Sumo bot. If you're ready, let's get started. The first thing that we will do is program our K-12 robot to produce sounds. So just like before, let's open our Arduino. It's right here and the Ardu block. So there. Again, the very basic thing that we should place in our Ardu block is the kbot.begin. Next, we will go again to K-12 bot block, and we will select kbot siren. Let's place it there. And as you can see, you can so there. That's the sound of an alarm. Let's change this to horn. Let's keep it low. So that's the horn. And let's change this to Mario. There. How about an ambulance? Let's click upload for the ambulance. Yeah, that's weird sounding ambulance. Let's change this to police. Click upload. So there we have it. It's that simple to use these pre-programmed sounds that it's available in our Ardu block. Now the next thing that we will do is we will program our Ardu block, our K-12 robot to become a Sumo bot. The idea behind a Sumo bot is first it will have to look for its opponent, and then once it found its opponent, it will move forward to push the opponent out of the playground. So to do that is we need our sensor. So first, to make sure, let's print the data, and then let's get the value of our sensor, which is the ultrasonic sensor. Next one, I'm going to introduce to you one of the most commonly used and very important block in Arduino block, which is the while loop. And this is the while block. Let's put that there. And just like before, what we would like to know is that if the sensor reads that there is an opponent which is less than 10 centimeter, it will push that away. So let's get the test block and let's get the less than. Let's clone this one, place it there, and let's get variable constant there. So from 1, let's make it 10. Alright, so basically what we're trying to do is if the object is less than 10 centimeters away, what we would like to do is push it. So let's place the keyboard motor forward, and let's do it to the max, 255, and let's also put some delay. One second delay is okay. And then to be able to go out of this loop, we will have to put in a break block. Break block is right here, so let's put it there. And that completes the routine when there is an object which is less than 10 centimeters away. The next thing that we will do is to find for an opponent. So to do that, let's use the if block. Let's place it here, and then let's copy this one. Let's clone that. Okay, so this is less than 10, so let's make this greater than or equal to 10. And what do we want to do if there is no opponent? First, let's move forward. Let's remove the break, and let's move forward for 200 milliseconds. And then after moving forward, then we will turn left to find for the opponent. Just let's clone that. Let's turn left for just 100 milliseconds, and let's change this to actually extreme left. Alright, so basically what it will do is once there's no opponent, it will move forward for 200 milliseconds and then turn left for 100 milliseconds. So it will just keep on rotating and looking for the opponent, and once it finds an opponent, it will go to this section and it will push the opponent away from the playground. Let's upload that to our Arduino, and there I see that the motors are working. program tonight, mga katry, we would like to answer one of the questions that we received from one of our viewers. The question was about what type of motor and batteries to be used, because he is designing a robot that will carry a 1 kilogram payload, meaning to say his robot will have to carry 1 kilogram load. So what type of motor to be used, as well as what are the type of batteries, or what are the specs of the batteries to be used. Well, first of all, mga katry, in designing what type of motor to be used for our robot, that is a good idea that we start from what is the purpose of our robot. And in his design, it seems that speed is not a problem. What his concern is the weight that the robot can carry. And if the robot will have to carry 1 kilogram payload, well, that means that you also have to consider the weight of your robot itself. So let's say your robot will carry 1 kilogram payload, and the weight of your whole robot itself will have to be 2 kilograms. Then that will be a total of 3 kilograms. Then you have to decide to choose a motor that can carry 3 kilograms payload. And so how do we know if the motor can carry 3 kilograms? Well, if you look at the specs of the motors, usually you will see the word torque, and it's measured in Newton. Then all you have to do, for example, the motors, it says it can carry 5 newtons. Then just Google it, convert Newton to kilograms, and you would know if your motor can carry that load as heavy as 3 kilograms, or depends on your application. And then what types of batteries to be used? If your motor runs on 12 volts, then your battery must be 12 volts. It cannot go over that. If your battery runs on 5 volts, then your battery must be 5 volts. If it's in between, it says 5 to 12 volts, then you can choose in between 5, 9, 7, or 12 volts. That's okay. Now, how about the capacity of the battery? The capacity of battery is measured in milliampere hours or ampere hours. So how to measure the capacity of the battery to be used? Well, first of all, you have to measure what is the current draw of your motor when it's fully loaded. Meaning to say, if there's a load, what is the current that it is drawing? For example, at full load, your motor is drawing 250 milliamperes of current, and you have 4 motors, then that means you have to have a 1 ampere, or you have a 1 ampere load. And so if you want your robot to run straight for 4 hours, then that means your battery capacity will have to be at least 4 ampere hours. So you will have to design, make a combination on your battery to be able to provide 4 ampere hours for your robot that will run for 4 hours non-stop, and each motor has a full load capacity of 250 milliampere. That's it for tonight, mga katry. If it's your first time, you can watch the previous episodes of our Try Robotics series. And also, please don't forget to click the like button and follow us on Facebook as well as on YouTube. See you next week.